Looking at the problem set for lesson 1, the first question asks us to find which two cards I could have with a sum of negative 12. So, the easiest would be 0 and negative 12. That's not the only option. Usually people think about negative 6 and negative 6. It's the next option. Then maybe we have negative 1 and negative 11. Okay, there are many possible options here. We could also have negative 2 and negative 10. And I'll display all of the answers here so that you can compare to yours. So here are all of the options that we could have using the integer card game. That would give us a sum of negative 12. Next, what if I added 2 more cards, but the total sum of the card remained negative 12? So in order to add more cards, but keeping the sum the same, I am using the identity property. So the identity property of addition says that I can add 0 without changing the value, which means in this case, to add 2 cards, of course I could have 2 zeros, or I could have a pair of additive inverses. Now this could be any set of additive inverses. For example, negative 5 and 5, or 10 and negative 10. Basically, additive inverses would be a set of numbers that are opposites. They have the same absolute value, but different signs. For number 2, your task was to choose one card value and its additive inverse, and then choose from the list below to write one real-world story problem that would model their sum. So for this one, I will choose temperature, and I'm just going to verbalize mine instead of writing it down. On Friday, the temperature rose 5 degrees. Friday night, the temperature fell 5 degrees. What was the total change in temperature? So if I had a rise of 5, then a fall of 5, together, that would be a change of 0. And I have used a card, 5, its additive inverse, negative 5. The final problem on this page, on the number line below, h and k are the same distance from 0. That means they have the same absolute value. I'm going to write an equation to express the value of h plus k. H plus k equals 0. Now, just to kind of prove that, I'm going to assign a value for h and k. So what if k is the number 4? Then h would be its opposite, or additive inverse, so it would be negative 4. Negative 4 plus 4 is 0. Regardless of what number we have here for h and k, we know they're the same distance from 0, which means they have the same absolute value, which means h and k are additive inverses.
All right, let's take a look at question number 4. During a football game, Kevin gained 5 yards on his first play. I'm going to pause and just underline that. He gained 5 yards, and as we reflected at the beginning, that could be represented by an integer of positive 5. Then he lost 7 yards on the second play. Again, I'm going to underline lost 7 yards. That would be a negative 7. That's how I'd represent that. How many yards does Kevin need on the next play to get the team back to where they were when they started? Show your work. Okay, so I've already created a number line for us. It's 0 to 10 and 0 to negative 10. Let's start at 0. We're always going to start at 0 on our number line. And the first thing we want to do is show a vector of 5 to the right. 1, 2, 3, 4, 5. 5 to the right. And that is a gain of 5 yards. Now, on the next play, it says that he lost 7 yards, so we need to start where we stopped on our previous vector. And we are going to go 7 to the left. I think it's interesting to look that these kind of cancel out. There's 5 spaces, and I'm going to go 2 more spaces. And that's a vector of -7, which you could see is kind of decomposed of -5 and -2. You see here's an instance of our additive inverses, our opposites, 5 and -5, and we're left with -2. So now we need to figure out, how do we get back to where we started? Well, we are currently at -2, so to get back to 0, we would need to make a move of 2 in the positive direction. So he would need to run for 2 yards on the next play. All right, let's look at number 5. Write an addition number sentence that corresponds to the arrows below. Now, this question leads to some misconceptions, and hopefully we can draw those out. There's 3 arrows here. Which one do we start with? How do we know which one we have to do first? I see multiple moves happening here. I could probably identify this as a vector or a jump of 10. I could identify this as a -5 and a -5. How do I know which vector I should begin with? Well, we always begin at 0. So which of our vectors is starting at 0? It is this positive 10. So my first move here is 10 to the right, so my number sentence is going to be 10. And it is an addition number sentence, so plus a -5 and plus another -5. And -5 and -5, we know that that makes -10. So 10 and -10 are additive inverses, they're opposites, and as you see, we end up back at 0. Okay, number 6, there are a few strategies for this. I'm going to show you 1 or 2, but what our goal is here is to end up back at 0, and we are adding multiple integers together. In the first one, we're going to add 3 integers. We're given 40 and -30, so I'm going to represent 40 as a vector of 40 to the right. Now we're told that -30 is one of our values. So if -30, what would be the rest of the vector that I would need in order to get back to 0? That would be another vector of -10. -10. Here I have negative vectors of -25 and -10. So what vector would I need to get back to 0? Well, I would need a vector that has the same absolute value as the sum of those 2 vectors, and that would be 35. Let's come down here where we've got some more space. I see I need 4 vectors here, -20, 60, and 2 other vectors. So let's just start with a vector of 60. If this has a value of 60. And then I can even just kind of break this up into 3 pieces. If I know that I'm going to have a vector of -20, I have how much left? Well, I know that I need 2 vectors together that create this difference of -40 here. So I could have a vector that is -10 and -30, -1 and -39. I could have any combination of vectors that have a sum of -40. I could even have another positive vector potentially, and then a negative vector with a greater absolute value. So let's do -15 and -25. And that would be -20 plus -25 plus -15, -60. and 60 and negative 60 equals 0. Right. For D, basically going to do the same strategy, or we could think about it, let me model it a different way. If I have negative 65, I'm going to take the number with a greater absolute value. I want 4 numbers that are going to add up to negative 65, or excuse me, 4 numbers that are going to add up to the opposite of negative 65. So I could decompose this down into 4 numbers. So that would be, in this case, 30. I know that these 3 are going to have a sum of 35. 30 and 35 is 65. So we could do 10, 15, and 10 again. And that would give us positive 65 over here, negative 65, and that would give us a sum of 0. So fill that out, 10, 10, 15. All right, there you go.